Hello and welcome to today's episode of Rawkode Live at the Rawkode Academy. I am, of course, your host, Rawkode. Today we're doing something a little bit different. It's clustered, but not clustered. We're taking a look at the changelogs, real production infrastructure running on Kubernetes, which has a small networking issue that we are going to attempt to debug and fix live for you today. Please remember to subscribe, click the bell, share, like, comment on all of these videos. It helps the YouTube algorithm be nice to me and make these videos discoverable to other people. We also have some membership options available if you wish to support the Academy. They range from $1 a month to a little bit more, which gets you access to private and featured videos and courses, which are currently being worked on now. And we have a rather active Discord server. There's almost 600 people in there now, talking all things cloud native, Kubernetes, eBPF, and everything in between. There's a lot of excitement about the new Dune movie and Matrix movie. Hence, I'm wearing this t-shirt today. All right, that is the housekeeping over. We are going to say hello to today's wonderful guests. Hello, Gerhard. Hello, Marques. How are you both today?
We're good. I'm good. Marques looks good to me as well. So we're good.
I'm wearing a Changelog shirt.
Oh, nice.
I'm just a weird fish. I'm still waiting for mine.
All right. For people that are not familiar with either of you, can we start off with a little round of introductions? Gerhard, would you be happy to go first, please?
Yes. Hey, I'm Gerhard. How's it going? I'm the host of the Ship It podcast on changelog.com. And episode 18 just came out where I had David and Marques were discussing bare metal meets Kubernetes. So it was only, I think, fair and good to return the favor and do Rawkode Live. There's a real problem. David and Marques were curious, which I really liked. And today we're going to try and debug it to see what is the problem and how can we fix it.
Awesome. Thank you very much. And Marques.
Yeah. Hi. I'm at Equinix Metal. I work on all sorts of integrations. And I'm curious about the problem. I'm curious about how Changelog keeps things running, and I'm really dreading, just as in a clustered episode, kind of dreading trying to figure out what went wrong.
Yeah,
I'll be very disappointed if we don't take production now down, right? So Fridays, you shouldn't deploy on a Friday. You absolutely should every day, right? Be deploying multiple times a day, please. Ship it, keep shipping it. Not only that, but Friday is a great day to break things and just see how reliable your system is. Because if you want to take Saturday and Sunday off, you better be sure that everything works the way it should.
Well, I do have a knack for breaking things, but I'll do my best today, I promise. No, this is really cool. We've never done anything like this before. We obviously have clustered where we have very terrible people doing very terrible things to all of our clusters. And it's also almost masochistic trying to fix it. And I don't know what I'm dreading more, like Marques, like clustered, I know people are intentionally breaking it, but real world problems are debugging. Like there's nobody to give us answers. There's no hints. That's what worries me. But I think it's going to be a whole lot of fun. And you two are two of the smartest people that I know. So I know that we're going to smash this today. Not that I'm putting the pressure on both of you right now.
Thank you.
I'm just walking away.
Yeah, I was just going to say thank you for the pressure.
All right. Okay. So we have your screen shared, Gerhard. So I'm going to pop that up. There's our episode that we recorded. That was a whole lot of fun. Thank you so much for inviting us on. I really enjoyed that session. And it went live yesterday. Is that correct?
It did, yes. So in my mind, first of all, we have to top that fun. It has to be more fun today, and I hope it will be, because it's like a real problem. Anything can happen. Again, I will be disappointed if production doesn't go down. So that's one of my goals, to take production down, right? You don't hear this every day. And proof, right? Here it is. So I was really looking forward to that. It's in the show notes. Yeah, really excited to see what happens, literally. So let's see what happens.
All right.
And just like that, I listened to the whole thing before I retweeted it. I just want to make sure I didn't say anything that I would regret.
Okay. And did you?
No. My audio, my kid said I sounded like I was talking from a tin can in space. So I'm on a different microphone today.
Right. Well, I was going to say, why does it sound better? Because it sounds better.
Yeah. What I thought was great about that episode is I sounded terrible. And anyone who's seen anyone who's seen my show before knows that my audio quality ranges are all over the place. Sometimes it can be okay. Sometimes it's absolutely dreadful. And you actually spent a bit of time with me before we went live and actually walked me through fixing that. And I'm eternally grateful for that as well. And my audio the last couple of weeks has been astoundingly better. So
I know. I did a favor to myself because I listened to your videos and I follow your videos, and I thought, I just have to fix that. So I'm enjoying them a lot more. So yes, you're welcome, and thank you.
Awesome. So could we maybe get, are you happy to give us a bit of an overview on what does the Changelog production infrastructure look like? What have we got running here?
Right. So I spent quite a bit of time with metrics, with logs, with graphs, with that sort of a thing. And I knew that you wanted me to prepare some slides, so I did. The slides are actually Grafana dashboard running on Grafana Cloud. So yeah, this is something new. I haven't done it like this before, doing like a semi-slideshow in the Grafana dashboard, but that's exactly what this is. So a link to the actual what's happening right now for people to follow, the follow-up. The changelog application and infrastructure setup, everything is open source. So if I click that, go to GitHub, everything is there. So application code 2021, this is the whole setup. There's some make files, various things that we use, and we'll be looking at what it looks like once it's configured. But I would like to come back and look at this little thing. So this is how everything works. From the requests coming in to changelog.com, all those requests are served by Fastly, CDN. They serve a lot of traffic, and as a result, our backends, they don't see a lot of it. So 90%, 95%, it's all cached. So most requests are served by CDN, by Fastly. Then we have a Linode node balancer where the requests come through. And this is just a TCP pass-through. So there's no TLS termination, nothing like that. And this is where the fun starts. This is where we'll be focusing on. There's a Kubernetes, LKE, managed Kubernetes. It's a single node. Ask me all about it. There's a very good reason why it is a single node. And behind that, we have Ingress Nginx, Phoenix, and PostgreSQL. So it's a typical 3-tier app. It's monolithic. Ingress Nginx is the web layer. Those requests go to Phoenix, which is like an application. That application has a volume. It's using like a local path, local storage. The persistent volume, that's the uploads, where all the MP3s are stored, all the media stored, thumbnails, all that stuff. And then we have PostgreSQL, the database, which also has a local path database volume, which stores all the data. So fairly simple. The reason why this is okay is because, and this is the reason why, again, it's okay to take production down, because even if it goes down, Fastly will keep serving stale content. So all requests will be cached, and they keep getting cached all the time, by the way. And if the backend cannot, the origin, as it's called, cannot be contacted, the request will be just served from Fastly. So again, if this all works the way it should, if we take production down, the majority of the users, 95%, will be unaffected. It's only the ones that are logged in or, stuff like that. So if you are logged in, by the way, you'll know why it doesn't work. So using private browsing always fixes it. As long as there are no cookies, you're good to go.
All right. Well, I was so confident coming into this session that kubeproxy was going to be the culprit, but it's a single node cluster, so kubeproxy is not even doing anything. So right. that rules that out completely.
Okay.
What were some of the reasons why you went to the single node? So you hinted at it in Ship It the other day, and again. So you said ask me for the details, so I'm asking you.
You're asking me. Great. Okay, I was expecting that. Thank you. So before we went to a single node, we used a multi-node Kubernetes setup, right? As it's recommended, 3 nodes. What we have found out is various issues regarding volumes attaching and reattaching, so detaching and reattaching. So let's say if a specific workload would move around, we would have increased downtime because volumes failed to detach correctly and reattach. So I know that these issues were like early days, like beta time on LKE, and things have been fixed since. However, even after they were fixed, we were using clustered PostgreSQL. And for whatever reason, the reader, or like the replica, shall I say, would stop replicating. So then the primary PostgreSQL, the write-ahead log would fill up. It would fill up the disk. It would crash eventually, and you couldn't restart because the disk was full. So try resizing the volume. Really? Okay. So yeah, eventually you do fix that a couple of times, but then you wonder, would a single node fix all of this? And not only it fixed all the problems, it made us rely heavier on backups, for example, and it simplified so many things. So until recently on LKE, you couldn't get block storage backed by SSDs, like really fast block storage. It used to be slow. This is a recent change, like I think in the last maybe month, and only in a specific data center, this feature is available. But what that meant is that our database queries were slow. So it's crazy to have these Linode VMs, which have really fast local SSDs that you can't use because you're attaching a persistent volume, which is backed by block storage, which is 40, 50 times slower. So again, we solved a lot of problems by just going single node, use local storage, have backups, do them often, like every hour, and restore. Like we can restore really quickly from backups. And I test them regularly, but what hasn't happened yet is we haven't gone in a situation like in, I think since the beginning of this year, since we switched to single node, that we were missing a cluster. So what I'm saying is in practice, we tried both. And for us, single node is more reliable, faster, simpler. So that's why we chose that.
I love that. I think, especially with everything going on with Kubernetes and cloud native, is that teams are so quick to reach for horizontal scale to get resiliency and redundancy, when sometimes just really getting a tight feedback loop on backup and restore is a much more efficient and effective way to handle this stuff. So that's really cool to hear. I like that a lot.
Yeah. And one of the other things which I want to mention is a lot of people keep saying, why are you using Kubernetes? You have a single app. It's like so simple. The reason why we use Kubernetes is because we have a couple of concerns around it. Like, for example, generating TLS certificates and keeping the TLS certificates in sync between the ingress Nginx and the CDN. So we have jobs that we run that keep them in sync. We have like automatic updates, which are just baked in. We can use a lot of tooling very easily because everything is like in a container. We just pull it down and everything is like self-contained, well-defined. So the ecosystem around it makes it simpler. And we are avoiding some of the gnarlier problems, multi-node, big clusters, stuff like that. So it is simple, like almost like we're picking the good parts and maybe, not relying on the bad parts, or like not using the bad parts. I'm not sure how to say that, but we're picking the good parts. Let me put it that way. We're picking the good parts.
Yeah, I actually wrote an article in the same vein as this. It was called "You may not need Kubernetes." No, you may not require Kubernetes, but you definitely need Kubernetes. And it's like your technical requirements may not say, "Okay, I need all these features of Kubernetes," but the ecosystem and the tooling and all of these conventions, stuff that's out there that you can take advantage of, is generally a competitive advantage for most organizations, even if there is but maybe a significant learning that has to happen to be able to run Kubernetes. But then that doesn't mean you have to operate Kubernetes like you're doing. Like you're using a managed service and then just picking the bits of Kubernetes that you need that solve the problems that you have. Yeah, a very wise way of doing it, definitely.
Also, not doing in-place upgrades. Always like set the new one up, restore from backup, try it out. Yeah, like blue, green, everything.
Are you using really Valero for your backups?
Nope.
Just standard Postgres tooling to an S3 bucket on.
I can show you how that works in a second. I mean, do you want me to do that or show you the problem? Like, what do you mean to do first?
Yeah, I mean, we could just have fun taking a look at the changelogs infrastructure, but we are here on a mission, so maybe we should. Oh no, okay, go for it then.
Git remote V. I mean, it'll be really quick. So git remote V. I just pulled it down. CD 2021. That is the directory which currently stores all the config. Where am I? PWD. Yeah, I'm already there. So I have to source env. That's the first thing. It just contains a couple of credentials using LastPass to set my local environment up to get me the tokens and everything that I need. And once I have that, I mean, make targets everywhere. But if I do make canines n, these are all the things that will run in the background. So make canines, it's an end curses interface. And just as you're used to maybe using Vim or TIG, which is an end curses interface for Git, canines, it's an end curses interface to Kubernetes. And this is what it looks like. I can see all the pods running in this LKE managed Kubernetes cluster. And it's that simple. Once I'm here, I can do pretty much anything on production. So you're asking about backups, okay? So let's look at the namespace, prod 2021. This was when that was set up in April. This specific instance, we can see the version 1.20.10 of Kubernetes that we're running. And you can see these backups, these pods, they're from there's a cron job which runs them every hour. The app instance, the database instance, and there's a pod, which all we have is like to be able to restore the database. Now, if I restore the database, it's gonna have everything inside, like drop all the connections. It has like to do a couple of things. And all that is self-contained in a pod, in a container image. So all I have to do is jump there, run a few commands, and it happens. So I wouldn't say it's ClickOpsy, but it's terminalopsy. That's a thing. I don't know if it's a thing. Maybe it will be as of today. So let's have a look at cron jobs. So we have a backup.
Is it cron-ops? Has that been coined yet? Yeah, cron-ops.
Maybe this specific thing, but no, like the rest, everything else, I don't think it's cron-ops. I think it's my terminal and me typing and doing things. But the cron jobs, there are only two, right? One which runs the backups. And the backup job, this is what it looks like. In terms of the description, I think I maybe would have wanted to do an E to edit it. And now it's opening the terminal, loads all the secrets. All it does is just like, runs some commands. That's it. Which is, there is an image. There's the image, the changelog backups. And it just runs commands and it knows how to back up. So let's trigger this job. How about that? If we were to trigger this job, this is how simple it is to trigger an ad hoc backup. So Control T. Did I trigger? No, T. Yes. Let's do a backup right now. Live backup. Let's go back to pods. We'll see the new backup, manual one, container. Let's look at the logs, starting the database backup, starting uploads backup. So it backs up everything to S3. It takes a database dump, streams it to S3, and it synchronizes all the uploads, all the media. There's like a few new files, and it does that's like an incremental one. There's a new episode of JS Party that was just backed up to S3. There you go.
Have you seen this interface before, David?
Yeah, K9 is quite popular by people in clusters. So.
No, I have to watch more episodes.
And the database backup, how long did it take? Starting 450, 24. No, that was too quick. Starting 450. Actually, no, it wasn't too quick. It was 20 and something seconds. So 21 seconds later, we've backed up the entire database. I mean, when it's this simple, restoring takes maybe 2 minutes. That's it, the entire data. Like, what more would you need than this? So, okay, so we took a backup. How about we open a shell in this container and we look at backups. That's like an autocomplete. I don't want to back up. I want to do S3 backups. And this will list all the backups. So this is the backup that we just did. This one right here. This is a database backup. And as for the media, it's just like synchronized here. So everything is backed up to S3. And by the way, it just needs an S3 compatible store API. In this case, we use AWS S3, but it can be anything really.
Nice.
So there you go. That's how simple it is to take a backup. And that's what it looks like from a perspective of pods. I mean, what else would you like to see?
I mean, we can hold off on the restore till we break some stuff if you want.
Yeah,
yeah, I think so too.
Why don't we... So K9s is a really great interface. I like that you're using that. Maybe we should take a look at what the problem is and give people a bit of an idea about what we're going to try and debug today.
That is a good idea. Sure. This is, by the way, an overview of what we have running right now. This is what production means. This is what changelog production looks like right now. The memory we just over allocate because we cache a lot of stuff in the app, but it doesn't need that much memory. And again, single node. So what is the problem?
Gerhard Santo in the chat who said he just shipped that episode of JS Party. There you
go. Hey, Jared. Great. Well, it's backed up now. And if we wouldn't have backed it up manually, in the next hour, it would have done it directly. So great. Well, it's backed up. It's all good. Cool. So coming back, what is the problem? So let's close the intro. We understand.
Yeah, slide 2, please. Next slide.
Slide 2. Yes, slide 2. So let me close slide 1 and let me open slide 2. So what is the problem? Okay. The problem is that the web response times are, and if I have to bring up the intro, it's basically this layer, Ingress Nginx. The web response times sometimes are slow. Does anything look slow here?
Well, we have a couple of outliers, but nothing that gives me any cause for concern.
Right. The reason why is that because we're looking at the 90th percentile. So if we are looking at the 90th percentile, 90% of requests, they complete within some 200 milliseconds. I haven't seen any. I mean, I can zoom in to see something specific if there's any outliers here, but you can see that the 90th percentile, within 300 milliseconds, they complete.
Yep.
Okay. What about the 95th percentile? Okay. 500 milliseconds, slightly worse, but nothing crazy, right? We have a few which take maybe, this is 2 seconds here. This one right here, I wish it would highlight, but it doesn't. It's just around the 2-second mark. But what about the 99th percentile? There you go. This is a different story. So some requests can take a minute and a half. So why do they take that long? Why do certain requests, like at the tail end, take that long to respond? I mean, it's a single host, right? Ingress Nginx talking to the app. It's all local. Any guesses?
But this isn't all static content, is it? This is dynamic content.
Well, I think there's some
what
dynamic.
Differs between what differs between the endpoints that are experiencing this and the ones that are not?
Yeah, I'd want to see
Okay.
I think what Marcus is saying is a histogram of the endpoints to see if there's any groupings of the anomalies on a single endpoint.
Yeah. So that is which responses are slow, right? That's exactly what you're asking me. Slide number 3. I'm going to open it up now. We have to slow down because we'll go through too quickly through the slides. I will have like loads of time left. So slide number 3, which is telling us is that this one is a get to uploads podcast 458, the changelog 458. This took 2.39 minutes. So we can see if we sort them by max, a lot of the ones, actually all the ones that take minutes are the MP3s.
Yeah, the media files. Yep.
So what are you thinking?
So those media files, are they just files on the disk locally? They're not being pulled from S3, right? They're backed up to S3 but served locally.
That's correct, yes.
All right. So we've got something. I'm assuming that there's a single endpoint in your Phoenix application that does delivery of these MP3 assets. Or
yes.
No, these aren't going through Elixir, right? These are direct HTTP requests to the file through the web server.
No. The Phoenix app serves them, but
okay.
You don't have to worry about like scaling on the Phoenix side because it just uses all the CPUs. So like every single request will just use as many CPUs as it needs to use. So every request will use like one CPU core. So there isn't a bottleneck on the Phoenix side.
Okay.
I mean, obviously they're being pushed, right? And it's like the clients, however long they take. But I think there's something interesting happening here. And I don't know whether this does a good job of showing it, but look at these. There seem to be like many of these which take about a minute.
I mean, is it just the size of the files?
It is. I mean, they're big files.
I mean, are we able to break down where the requests came from for these files?
Where the requests came from? Well, let's have a look at that. So let's explore the upstream responses which take more than 10 seconds. Okay. So all the upstream response times, they take more than 10 seconds. So let's see. This one, for example, request time 61 seconds. JS Party. This is everything that we see about this request. Anything that stands out?
I like the comment there about MIME typesetting and gzip not turned on in the Nginx config. I also wonder if it could go the other way. So like if the client didn't, if it's a special client making the request and that client doesn't have gzip encoding support, we would be able to tell that from the headers what the client requested. But we're talking about MP3 files, so they're already compressed. So I don't think that's an area of concern. I also wonder when all these requests are coming in, this MP3 is slow. So my thought was, well, you're running on a VM. Maybe your VM is hitting some kind of I/O contention, and maybe the disk really is running slow at this moment in time. But if you're receiving other requests that are being served at the same time, then maybe that could show that it's not a disk I/O problem. But we can't really tell that because other requests might be getting served directly from cache or kernel file system cache.
Okay.
So I've given you a lot of nothing.
Well, you gave some ideas. Like I like, again, this is like the whole point. We're doing this so that we run through various ideas and we see like what could it be. And the goal is to show how we interact, how we discuss about this problem. So what I find really interesting is that we have like a whole band of requests, which are around like the 60-second limit. And that is meaningful. The other meaningful thing, I think, is the status.
Yeah, the partial content.
206. Exactly. So the way I understand this is that we are streaming these responses, right? Because they're like MP3 files, and it just depends what does the client want, and we stream them based on what the client is requesting. After 60 seconds, I'm wondering if there's like another request which is opened, right? Because I don't think these are long-lived. I think they have like a max time, and then they stop, and then maybe another one opens, and then continue streaming. So we could filter them out to see which ones are non-206 and see what happens. gzip, that's an interesting idea, but these are MP3s. So, and as far as I know, they don't compress very well because they're already compressed. So I don't think gzip will make any difference. I'm wondering if the reason why this is the way it is simply because the application is serving data, binary data in this case, which it has to be streamed, right? That's how users listen to MP3s. And it's literally like that streaming thing that just takes time, right? Like the TCP connection is open and you're streaming chunks. And that's why the status is 206, partial content. It closes the connection and then it opens another one. And you have to tell it, okay, so where do you want me to continue streaming this file or like serving this file from? And I think that's what's happening here, but I'm not sure.
Okay, so can we take that query and group by status to see the breakdown, the distribution?
So let's see, how do we do that? So it's sum by, would be sum by, actually, I think it's this query. I think this is the one that we would need to work with. So this one is max over time by method and path. What else would you like us to add? Would you like us to add?
Status.
Status, great. So let's do method, path, and status. All that we need to do, shift enter. So status, even though it grouped it by status, we don't see the status. And this is where, let me just hide that. Let me come down here. So let's just add a status there.
We're not going to be able to group very well by user agent, but I've seen different user agents handle partial requests or ranged HTTP requests differently. I tried to implement a streaming service using just range request options available in the spec or sort of vagaries of the HTTP spec that I observed that browsers were handling the requests differently. You could now I'm not going to remember what the exact syntax was, but if the browser requested a certain range on the server side, I tried to give them back less than what they requested and have them come back for more in a way so that I could sort of do a per minute charge of what they were doing. I could see how much content they were requesting and if they tried to request the entire file, only give them back part of the file. But that was only possible because different browsers handled the requests in different ways. Firefox versus Chrome even. So if we tried to see if the problems that we were getting here were one browser or another, that might tell us something, but I don't know that we're going to be able to group that very well in this tool.
So that's a good idea, but I'm wondering if now we have a problem. Like, do we have a problem, or is this behaving the way it should? And when we are looking at all the requests and grouping them all together, then some requests, like for example MP3s, they behave correctly. They will take 60 seconds or more based on the speed of the client.
So we have a question in the chat from Carlos who's asking, yes, are all of the 60-second requests partial contents? Which I think is something we all want to know. So.
Okay, let's have a look. So upstream response time more than 59, and upstream response time less than 61. Less than 61. 206, 206, 200, 206, 200, 206. So it's a combination of 200s and 206s.
Can we change the visualization to a histogram on status?
Can we change to histogram? I can try, but I don't know how that's going to be like. So hang on. No, that's not what I wanted. Why did this break? Oh, there it is. It's my E there. I added an E. Cool. So let's go to graph. If we change it to histogram, oh, that's the type. Yeah.
I know the influx.
Histogram.
There we go.
Histogram. I don't think that's telling us much, really.
No, not what I was hoping for.
No, we have to mess with this, and again, I'm not sure how exactly that would work. But so why did you want a histogram?
I wanted to see the distribution of 200 to 206s. I guess we could always just do it in a really hacky way and maybe do a count unique of the status, just so we could get some sort of number.
If you know what you want, walk me through it and I'll write it.
No, I'm not a Prometheus person. I'm an InfluxDB through and through. So I'm.
So interestingly, this is not Prometheus. These are log QL queries.
Oh, so this is Loki.
Right, this is Loki, exactly. Yep, because we're looking at the logs, and that's what we're working with here. So what did you want to do, David, again? Tell me so that I can...
Yeah, if we could get... Maybe if we just do by status and then do a count of that value.
So by status. Okay, so let's group them by status, maybe. Let's do, and that will give us fewer. Let's see, that does something. There we go. So we see the 200 and the 206s. Do you want me to remove this? Or is this what you wanted to see?
Yeah, I guess that's close enough. It looks like what? 1, 2, 3, 4, 70-30 split. So it's mostly 206s with some 200s.
Yeah.
I mean, that aligns with the hypothesis we had, is that maybe this is working as intended with the partial content and the media files being streamed over potentially slow connections that make it take a bit of time.
Yeah, that's what I'm thinking too.
Could we filter it to a single file? I'm wondering if that would reveal anything, just to take out the variability of these are different files.
Okay. Yeah, that's a good idea. So let's do path again in status. And let's do actually group by path.
So I'm wondering if maybe some of the MP3s are compressed differently or are more compressible or are larger sizes. So let's kill the fruit salad and turn this into like an apples to apples comparison.
Yeah. Okay, so we are grouping them by path now. This one, for example, but we're limiting the upstream response time to 59 to 61. Do we want to expand that a little bit? Because this is constraining which responses it's going to show us. And I think we want to have more. I think we want to have more
we
than
can probably do anything above
filter at all.
30, 20, like anything that's not normal, and then
there you go. So if we were to look at this one, for example, go time 196, we have an interesting, I'm just gonna, can I make this? I can't make this bigger than this, unfortunately. I could maybe hide the, anyways, if we look at this, majority take a minute.
I think if you do VF, it'll full screen the graph.
VF. No, I think it's just like the resolution.
All right,
just limit so that everybody can see. So what is our audience saying? I think we have some good suggestions.
Yeah, so Carlos is agreeing that this is maybe just standard behavior. The 206 is what's expected. What else have we got?
That's exactly what I'm thinking.
Request is going to be a smaller request than like a 200 request. The 200 is going to be, I've delivered the entire file to you. The 206 is going to be, I gave you some subset of the file. So I'd expect the 206s to be slower, not longer.
So these are the 200s. We can see for this like go time file, how they are distributed. The majority around 1 minute. We have a few outliers here. And for 206, we have one which takes a minute and one which takes 2.6 minutes, 2.7. That's it. We can. Yeah.
Why don't we try and confirm our hypothesis then? And let's filter out the uploads directory and look at the median response time of just standard pages. And then if we see anything that is an outlier.
Yes, that's a great idea. Okay, so I'll go back. I'll just refresh so that no, that's not what I wanted. Stay on page, slides. Let me just refresh this. Yeah, leave page. I don't care about any of the changes. I want to reset back to like a good known state. What is the problem? Let's look at that. Let's take the 99th percentile. Let's look at the web response times. And let us exclude, and by the way, we're excluding all the health requests, which is a good one to do. But I think what we want to do is exclude everything which doesn't include MP3.
Yeah, I think that's a good idea.
Let's just include all MP3s. Exclude all MP3s.
Oh, look at that.
Nice.
That's what you want.
If we exclude, we have like a few. I know there was an event there, so let's just ignore that for now and let's focus on this. And maybe let's come back to see this. So what do we see now? So if we don't take into account the MP3s, this looks a lot better. Most requests are under 1 second.
Yep.
And I think we'd like to understand a bit more what happens with those requests. So let's just do that. I'm going to refresh the page again. I just remind myself that I have a slide. Which responses take over 1 second, which are not uploads? Look at that. It's almost like I could foretell that's like, we're going to get there. Look at that. So we see all requests get sitemap. That is the one which takes many seconds. But that
probably quite a big XML file though,
exactly. Right? It's querying the entire like master feed. This takes a few seconds.
Is it a generated URL? Like just because it says sitemap.xml doesn't mean that it's not a dynamically generated page?
It is a dynamically generated page, yes, it is. Okay. And it has to query the entire database when it gets generated.
Are your MP3s served as like static content, or are they also going through a dynamic processing? Maybe the ranged requests are like I was describing. I tried to make my own media service that would cut things up. Mm-hmm. Is Nginx doing the partial range response request handling, or is this like, for lack of a better comparison, a PHP script that's reading this in?
Because the uploads volume is attached to the app, the requests go through the app. So we can't attach this volume to this pod. This runs like in a different namespace. It's like, so we need, like the app needs to be able to write. The app needs to be able to write to this volume when, for example, we upload MP3s. So the volume is attached to the app. The requests to MP3s go through the app, which is fairly fast to serve them, and I don't think that's a problem. It's just like we're seeing that the app, we're seeing the result of the app serving MP3 files, which maybe we wouldn't expect. So I think that we need to filter this out.
Does the app have hooks of some sort? So every time somebody makes a request, is it writing something to a database? Is it keeping track of, user activity in real time?
It depends on the
Possibly
request.
in process.
Not when an MP3 gets hit. So, for example, an MP3 request, if it's not cached in the CDN, it usually is. But if it's not cached in the CDN, then it has to go through all the stack. It has to go through the balancer, through the ingress, through the Phoenix. So the expectation is that the MP3s will eventually all be served from the CDN unless they expire. So the TTL on the MP3s is really high. So if we were to look, for example, at this one, let's take this one, and let's see what do we get if we were to query it. So let me just get out of here, HTTP stat, yes, uploads. So what do we get? This, by the way, we'll get it. So it's a miss. It's not in the cache. And what happened? Audio MPEG, HTTP 200. So what happens if we do that again? Now it's in the cache.
Gerhard gave us a message that there's no logic involved. It's Elixir's static serving library.
Yeah, that's right.
There's a few comments probably worth highlighting. So there's that one there saying, yeah, there's no logic. We've got one from Bogdan who says he's curious if we divide the response body size to the time of delivery or response, would that equal the bit rate of the MP3? I don't think we have that information in the logs.
No, we don't. No. And the bitrate is always the same. That doesn't change.
Yeah.
They all have the same bitrate.
Gerhard asks, how does the CDN play into this? Shouldn't it be handling those range requests directly and caching our MP3s?
That's exactly what I'm showing here.
Yeah.
So the first request was not in the CDN. I was expecting it to be in the CDN, to be honest.
Yeah, that miss kind of caught me off guard because I'm assuming people listen to these quite.
Exactly. I mean, we've seen the requests, right?
Yeah.
So how long should it be in the CDN? Strict transport security, E-tag.
Yeah, what's the cache control on it? The length.
Cache control public.
Can we include the cache in our in the filter?
The cache header, I'm not sure.
Do response headers? Yeah, yeah.
So let me see that. Let me explore. We have to go back to the Explorer. Let me close this one. And if we look at that, let's see what do we have here.
So this is all request, but do we have response headers of any sort?
That's it. Bytes.
Here's a question from Noel, which I think is quite interesting. And I'm curious if you know the answer. Well, Noel has a hypothesis first. So he says, is the client that requests a file on slower connection is getting it delivered in chunks with 206s, whereas faster connections get it in a single go? Does anyone know how that negotiation happens between the browser, the size of the file, and whether it wants to stream it or not? Like, is that even how it works? Because I have no idea.
The browser makes 206 requests, and the server can. So you request, like, you can say 0- to the end of file, or you can give a specific ranged request. The server is expected to deliver that entire range. The shortcut I was trying to make was to give the user less than what they asked for, which wasn't covered in the spec. If the user said they wanted 0-, the user was expecting to get the whole file. I believe that there's also, if you make a regular request, the server can refuse to do that and tell you to make ranged requests. And if your range is if your range size is wrong, I think there's HTTP error messages you can return, status codes you can return for range scoping problems. but the control, I think, is in the client's hands here.
Okay, so I mean, I'm still confused, which that's not an anomaly, right? I'm always confused. So how does, like, we've seen a lot of those MP3s with a 200 rather than a 206. Who makes that decision, the client or the server?
The client,
Or does the 200 mean
the
they streamed it all?
with,
Like,
Carlos said that the browser does an options first, and that sounds
the options would give
reasonable.
it the size, and then the browser decides whether I'm fast enough to do a 200 or a partial.
I think it tells the client that I'm capable of doing ranged requests, and then the client says I want to do ranged requests. When you send it, there's is it range? The header might be range that you send it in your GET request.
So does that range always happen for an MP3s?
I don't think
Because right now I'm struggling to know how to explain the 200s on the MP3 files. Because we did see a few.
Okay, so
is this the difference between a browser that knows how to play media and streams it versus something like, you know, a curl download, which would be a 200? Is it maybe just that kind of interface? Or right click and save as is a 200, but playing in the browser is a range? Is it as simple as that maybe?
What happens if you download this with curl and send it to dev null? We go to 200 and you serve the whole thing.
Yeah. So what if you do that on the Changelog website with DevTools opened? Are we going to see a 206 range?
So that's not what I meant. I meant changelog.com. And let's say this one. So if you were to play this one, let me open the browser. I'd see inspect element. That's the one. Network.
Yeah, so if we clear the network and keep an eye on that and then hit play, I'm curious what we see.
Okay. CDN byte range. I think this is the one. An error occurred while trying to put the resource rate. Accept request bytes. Varnish, miss. I'm not seeing the response though. Headers. Oh, 206.
Okay. All right, okay. So the behavior we're seeing is the difference between a download and playing it through the Changelog website, perhaps.
That makes sense.
You should see in the request, you should see that content range header. Was that specified here or not at all?
That's right. It was specified. Look,
nice.
It's right there. Okay. Range bytes. That's exactly right.
So now I'm learning how media works over HTTP.
So can we see this? I'm wondering if we can see this request right now live.
Do we have the request ID on the client side that we can put into locate?
Everyone in the comment thread hit this file at the same time, and we're going to see who gets it slowest. And we'll ask you what you ate for dinner.
That's a great idea. I love it. I love that. Also, I have to switch my lights on. Very important. One is done. Just 1 second.
Something else that I was considering and Googled, but I didn't find any great answers, was possibly that your caching backend is maybe having an easier time caching the entire file versus ranges.
I didn't hear what you've said because I was busy clicking. But we've loaded. So this one was which one was this? This one, changelog 458. This was a miss. So let's see if we can see it here. Right here, 458 changelog. I'm not seeing it.
Yeah.
But are they taking over 10 seconds? Because there's a limit. Are they taking over 10 seconds? Shipit FM, by the way, I think people must have been hitting this when I mentioned it. Do you see that? Like a lot of these, like the Shipit episode 18 was being played. So that's an interesting one. So
yeah, that's probably just my mom. We can ignore that one.
It is her, right? She really wants to listen to that episode. So if we remove that, if we remove the limitation and then we come back to the slides, what do we see? Oh, that's interesting. Let's just filter by MP3s. So to responses taking over. I think we already have this actually. So let me go back. Let me just refresh this. Yeah, leave. No, just leave page. Let's take which responses are slow. Responses taking over 10 seconds. JS party. Ship it. These are the only ones in the last 5 minutes which take more than 10 seconds.
Okay, so
oh, I see what the problem was. Yeah, go on.
I've got my dev tool set up on throttle the network to GPRS, and I am now playing 458. So you should be able to see that command, and it's definitely going to take more than 10 seconds with that throttle. One hopes.
Right. So which responses are slow, taking over 10 seconds? This is one which I want to edit. I don't care about the response. I just care that the path matches.
Maybe I was a bit harsh with the GPRS because it's not even started playing yet. It's buffering.
Yeah, these log query tools
there we go. There's me.
Things I've been looking for. I'm going to have to look into this a little more later.
So which one are you?
Are you that this orange one? Dot, yeah.
You're this orange one. Okay, so what happens if I request it again with curl? Oh, I want to request the same one, so let me just grab this URL.
Carlos is enjoying the introduction to Loki as we parse the Nginx log. So. Lots to learn.
So that was a 200, very quick 200. Let's see how time. Do I have time? I don't know. I just run the time. 1.15 seconds. Okay. So let's see. Start reloading every 10 seconds. Actually, no, that will be annoying if I do that. Let's just do off. So changelog 458, that's the one. 316 milliseconds. We could add the browser here, the, what do you call it? The method path, HTTP user agent, was it?
I mean, I can force my user agent to Rawkode or something if you want to confirm anything, but I think I can do that at least.
Go for it. We can get more Rawkode. We need Rawkode in our logs. That's exactly what we need. Let's get it. User agent. So now these will look a bit ugly because they're really, really long. We won't be able to see much, but Macintosh, that's me. 1014 there. Podcasts. Let's just focus on this one. But now it will do the grouping by episode as well. So those are like my two requests right there. Before and 1015. No, that's someone else. 1014. All right. You can use, yeah, okay. So what did we learn so far? Let's just like take a step back, big picture. We learned that these requests, the MP3 requests, they're the ones that are the slow ones most of the time. There's also the others, like the dynamic ones, which query the database big time. And we can have a look at the database metrics as well, by the way. Do we understand why some of them take to respond 206 and others 200s? I think we do at this point.
But we're not seeing a difference necessarily between 200s and 206s.
We're not seeing a difference in
long-running requests. Would we say that 206s and 200s, it kind of doesn't matter? It's just that we're seeing long runs on MP3s.
Right. So
have we ruled out the status code as indicative of the problem?
Status back in. Let me put a status down here as well.
So I couldn't set my user agent to Rawkode, but I have set it to PS4, which I'm assuming you don't have anyone listening on a PS4.
No, I don't think so.
So 206. If we can see a 206 PS4, then...
Yeah. So look, this 200, interestingly, here it took 1.83 seconds, but here it took 316 milliseconds. And if we zoom out, just to see a bit more, we can also see which one, this one, for example, ship it. Here it took a minute, which one was 206. When it was 206 0 seconds, that's not right.
It could be that they closed the tab though, right?
It's possible. But 0? Okay, maybe. So are there,
somebody did
is a good one.
arranged
Are there
request for nothing.
206? Say again?
If somebody did arranged request for 1 byte, 0 seconds.
154.
I think even that would take more than 0.
Yeah. So this one, interestingly, 200 and 206, look, both take 1 minute. 1 minute here, 1 minute here, but these are obviously different, must be different user agents or whatever. This one, HTTP user agent 206, 159, 154. So yeah.
Okay, can we check something? Just because I'm curious. I've been faffing around on my side, right? So for the changelog.com domain, my user agent is now set to PS4. Can we try and filter on that in the logs? We should see a 200 and a few 206s.
So let's do HTTP. What was it? Refer something.
It's the HTTP _user _agent.
Yeah, that's what I was looking for. And you want it to include what? PS4, did you say? PS5?
PS4.
PS4, okay. Caps? Lowercase?
I can confirm, but let's see if we see anything.
Okay. No data.
All right.
PS4. No data.
That's good. Let's see what I've got sent here. Oh, sorry, PlayStation. So the setting's called PS4, but it sends as PlayStation capital P capital S.
There you go.
Okay, so that's a 200 from the download that I did.
Yep. That's yours.
Yeah.
And it took 96 milliseconds. So you must have had a fast connection. What about if you have it slow? If you slow it down?
Yeah, I'm slowing it now. So right now I'm going to try and stream it on GPRS again and see what happens. Okay, it's spinning very slowly.
Still nothing. Nope, still nothing.
I guess we'll have to wait for the... No, we're not filtering on response, are we? Like, it's not a minimum of 60 seconds.
Yeah, no.
So that's weird. We're not getting any Nginx logs as I tried to stream GS Party 192.
Is the request not complete yet? Are you still waiting for your first block to return?
No, hang on. Look at that. This is get podcast feed. So this is completely different. HTTP user agent where it says play. Am I even like getting yours? Like PlayStation, did you say? You've put PlayStation in the refer?
Yeah, my user agent has PlayStation in it.
Nope.
Is it case sensitive?
No request. Yep.
Yeah.
PlayStation.
A capital S.
Right. Of course, you will do that. There you go. Those are yours, right?
Yeah. So my 200s are for when I download the file, and then we should see
2 seconds. Yeah, look at that. 200s, 458, 2 seconds.
And I'm streaming GS Party just now on a slow connection, but I don't see that there. Oh no, it is there.
This one. This one's happening right now.
Yes.
Yeah, that's your...
But why is it 200s and 206? That's thrown that whole thing out the window now.
I know, this one was 206. And this one now it's 200. And we can see we have multiples of those. Can it be that your... does it do ranges, by the way? Like, okay, let's do this. Let's take this one. And let's explore it here, because we can see the actual... There.
I was thinking about the not being able to show...
Those are PlayStation 4, yeah. Sorry, go on.
Those range headers, but we do have the size of the content that was transferred. Do we have that in here? So like if we were seeing 206s, then we'd see these were 206s for 1 megabyte or a few hundred K, versus when we're getting the full MP3 downloaded and maybe it's several megabytes.
Yeah, it's a good idea actually. Yeah, those 200s that we think are full downloads should have a consistent byte sent, I would imagine.
Byte sent 45302. 45302. Let's see this other one. Byte sent. This is a lot more. What about this one? This is the fav icon. No, that's something else. Uploads. No, that's already something else. So did you get anything other than... There's like a lot of stuff here which shouldn't be here. So this one is you for sure, PlayStation 4. This one is also you, 45302. Byte send, this is 194. Oh,
yeah,
this
so that
is
194 is me on the heavily throttled GPRS connection, which is probably why
Right.
the byte sent is so small. And I'm assuming we'll see loads of those.
But look, this got a 304.
Ah.
It's got a 304, and you got from CDN. Yep. So that's that. This one is a 200 from PlayStation 4. Byte sent. Okay. And this one is a lot more bytes sent. I'm not seeing any correlation here.
Nope, nothing.
Except this one. But this is the fav icon, so no. PlayStation 4. This is avatar, so that's something else. So maybe you should filter by MP3s.
And the 304s, I had to refresh myself on that. That's it's no content, but it's no content because it's a comparison against the cached value that the client already has. It's asking if what it has is still correct.
Right. Request time 2.4, 200, 2.4. This is a different one. Yeah, this is JS Party. This is the changelog.
Yeah, so the changelog I downloaded, and JS Party I'm currently streaming. But I'm not seeing the consistency I expected to see in the status codes. So it turns out I have no idea how media delivery works over HTTP.
Well, I'm still not seeing like the one that you're streaming, right? This started like 5 minutes ago. Is that when you started streaming it? I mean, no, because this was already finished, right? So this is a finished response. I think the one that is currently happening hasn't been finished yet. Must be, right?
It's still running, yeah, let's see.
So there's no log here. It hasn't completed. And it's not a partial one, so it must be still open. Can you control C it and see what happens? If you control C it, do we see it in the log?
Sure. Done.
Okay. There's nothing here, so let's wait for something else to appear here before we declare success. No, still nothing.
What we're trying to determine now is it's still figuring out if client throttling or client speed plays a major factor in the time that we're seeing.
I think what I expected to see is when I throttled my connection and requested the MP3 is that we would see the 206 partials with a consistent byte sent in a smaller range. But we've seen 200s as well, so I really don't understand how that works.
Are you sure that you got it from the backend? Are you sure that it wasn't served from the cache? Because
I can pick a different episode and I'll check the ones that are.
Keep
Better try
the same
go time.
Keep the same episode.
Keep dropping all the shows.
Yeah, keep the same episode. Just put 21 as a subdomain. That will go directly to the origin. That's like a little known secret. Nobody do that. Just go through the CDN. But there's a way to go directly to the origin.
Okay, so you want me to stick with JS Party?
Yes, just add 21 dot and then everything as it was before the URL.
Okay.
Okay, so it's streaming now, right? It's doing the thing that's supposed to do, that it's supposed to do.
It's trying to, yeah.
Okay, there you go. So now we have one right there. That was a 304. but that came through the CDN. So we don't want to see through the CDN. I'm wondering, bytes, and that was a 304, so no, it wasn't. Wait, refresh. There you go. That's another one. Okay, so 200, that's the host header. Now you're going directly to the origin. 200, yep, I can see it. Request 4 seconds. Yep, byte sent. So what do you want to test next? Like, we're seeing your request now from PlayStation 4.
So it's still buffering the MP3 right now.
This one was completed, according to this. Nope.
Was it completed? Is there a handoff? Is this sending it? Is there a server in between? And now the buffering is happening through some intermediary?
Well, no. I mean, the Nginx will have completed the request.
Okay, I think I'm throttling too much. I'm going to throttle it less so we can actually maybe see what we want to see.
Yeah. So this one was completed, right? Like, this is from the upstream. We can see what the upstream responded, and we can see what Nginx responded. So this is a complete request.
Yeah, I got a 304 not modified. I'm going to go to 191 instead of 192.
Yeah, 304. Yep.
I don't think either that episode doesn't exist or it's not loading. Should there be a GS party 191?
Right, you need to change it twice. Once, and there's 191.
Oh, yes, you're right. Okay, got it. All right, do we see that?
There was a 404. We've seen your 404 where you didn't update the second 191 or the first 191. And we are seeing this one as well. Yep, we're seeing it. 200 total bytes. Yes.
That 200 is a stream. Well, it looks like it's streaming on my side, so I didn't expect to see a 200. But.
Yeah, interesting.
I think I've got some research to do in my next bit of downtime.
Yeah, like, so that means that like the server completed the request. It's HTTP 2. That's interesting.
Is that what you're seeing from all of David's requests?
The request protocol.
I wouldn't imagine it would change. Yeah, I imagine they'd all be the same. I'm trying to figure out if there's.
Yes, they're all HTTP 2. All of them.
Yeah, so I guess HTTP 2 does streaming differently from HTTP 1. So I wonder if I even forced it to HTTP 1, we'd start seeing those. We could probably just do a grep on the 206s and see if they're all and group by the proto, right? And see if they're 2 or 1.
So you want to do status. Okay, so not from yours, right? Not from your end.
Yeah, we can do it across them all, yeah.
So go back here. So what do you want me to do? By
HTTP _ proto and status. You can probably just remove method and path if you wish.
Path is important. We can remove the method for sure. Path, we want to see the path. HTTP proto and status.
Yeah.
Status, HTTP proto.
Russell's got an interesting question there.
HTTP proto, yeah. That's there. Why are we not seeing it? Go back. Was it HTTP proto?
I think it was.
Request proto.
Or request proto.
Okay.
Now, this is just like clustered. Every time I get something wrong, it's my fault.
To 200. HTTP 1 200, HTTP 1 206, 200, 204.
So we kind of assume that we should never see a 206 in a HTTP 2, right?
Well, to confirm that, maybe we should. Oh, and this is just your user agent. So maybe I should remove that user agent and instead let's take the HTTP request proto. Sorry, request proto. Let's make the request proto be / Right. Let's see what happens. Okay, so 2.0. Let's just look at the request proto. How about that? I think that's what we want in the status.
And we're not going to see a 206.
No 206s.
Yeah.
Yep, that's right. What about when the request proto is 1.1?
206s.
206s, yep. Interesting. That's the last 15 minutes. Maybe we should go for longer than that. What do you think? 2.0.
Yeah.
So last 7 days.
No 206s. Or is it still querying? No 206s.
No 206s. That's right.
So put it back to 1.1.
1.1.
This is fun. I like this.
Great.
This is just one of those HTTP 2 enhancements is like streaming comes free.
Look at that.
Well, yeah, with HTTP 2, you would just get the response and then everything else would come behind it as subsequent responses. So they would all be 200s. But with HTTP 1, you'd have to indicate that it's a partial response. And then the next one would be a partial response and so on. So, yeah, it kind of makes sense based on my limited knowledge now, or at least more sense than it was.
Well, based on these observations, based on the data that we have on the queries, I mean, we group them by request proto. We can filter the status if we want to. So let's do status is 200, or status is, I think there's an easy way to do it, but let me just wrap it like this. Status is 206. And just feed it in. Okay. Should only see 200s. What did I do wrong? Status 200.
Yeah, I don't think that or will work because you can't have a status equals 200.
So I think I will need a regex, and I think I'll need to go for an or inside. Okay, let's do that. There we go. So 200, 206s. Do we see any difference? I don't think we see any meaningful difference between them.
No.
I mean, the two, they're scattered just about the same. What if we change the protocol to 2.0? Ooh, interesting.
Yeah, so the slower responses are
different, yes.
Chunked streams.
Interesting. Okay. Do we have any suggestions from the channel, from the viewers that we should?
Russell said something interesting that Marcus just said.
Yeah, does Nginx still have a connection to the client open after getting all the data from the Phoenix app? Similar thoughts, it would probably spawn by that. Could the data have all been transferred and we just haven't gotten a closeout of the request? Maybe Nginx is not closing it. Maybe the other side, maybe the application has sent the data that hasn't closed yet. That got me wondering about session data. So I don't know if every time these MP3 requests are coming in, if your application is doing some sort of state check, like check a session cookie that came in and then update it, refresh it, and kick it back.
No, it's all the Phoenix. Gerhard answered this really well. So if I go back, it's basically Phoenix. I mean, I can show the code, but it's in lib. There's like a root as far as I remember. No, that's something else. There's static. Is it here? Do we still have Gerhard's changelog web router? Static pages. Pages, uploads. Maybe I should search for that. Isn't there not here? We have all these plugs. Plugs. We don't have Gerhard. We lost that. So that's endpoint uploads. Uploads. There you go. Plug static. I found it. Plug static uploads from changelog, gzip files, headers. Circuit control. That's something which I was expecting to see. CDN static cache. Expecting circuit control to be set, but I haven't seen it be set, which makes me wonder. Let's see.
I'm really disappointed we haven't killed your infrastructure yet.
Okay, we can fix that really quickly. Are we towards the end of the stream? we can. Are we almost done?
Yeah, we can start wrapping this up.
All right, so let's wrap it up.
I don't know about you. I feel like we kind of almost worked this out. And
Yeah.
I think maybe what you've got is those anomalies, which we're talking about less than 1% are older devices or browsers, potentially older cars with some limited web functionality that's trying to pull down the file over HTTP1, which is causing the partial content streams, which are particularly slower than the HTTP2 streams. I guess the chunking mechanism is perhaps different. That's kind of where I'm at. I don't know if you both agree or you think something slightly different.
No, I would agree with that. Yeah, I would agree with that. I think that's a good good wrap up. We do see the 206s, we do see the 200s. We understand the difference between HTTP1 and HTTP2. I will do a follow-up research. We know that the MP3 files are the ones that are inflating the ingress nginx. That's why it suggests that sub requests are slow, but they're not. They're just like MP3s, which take time to be served, and sometimes slower connections can take longer. But slow clients. But what I don't understand is why aren't those MP3s cached by our CDN? Because they should be cached up to, I think, a year or 2 years. So once it has been served from the CDN, it should always be served from the CDN. Because what I've just done now is scale down the app to 0. So if you go to the origin, if you go to 21.changelog.com, which is the origin directly, this will not work. So production is down. Except, for like a regular user, you go to changelog.com, I'm signed in. Why this is happening. So if I go in private mode, changelog.com, I have my cookie. There you go. Changelog is up. Oh, it's not down. Now what happens if I play this? Will this work? And it works. So MP3s, this MP3 could be streamed, or at least it can start streaming. If you rerun your request, David, does it still work? The one without the 21, by the way. Let's confirm that
the 21 is definitely broken.
Yeah, of course, because that's the origin. The origin is down. Yeah.
And my CDN, when I change 21 to CDN, I'm getting a 503 backend unhealthy.
CDN?
Yeah, for JS Party 191.
Ah, that's interesting. Oh, yeah, I'm signed in here. CDN for
JS
JS
what we set out to do. We brought down the site. It's a good time.
We did, yes, right? At least parts of it. The uncached. So that's my question. Why aren't these MP3s, why aren't they stored longer in the CDN? And that's what I would like to dig into next. So for example, this one, sorry, go on. Follow up. Yes, that's a good idea. And this is working. If I go here, like, because I haven't listened it to here, will it still work? This still works. All the byte range, that still works. So I'm wondering, yeah, this is backend is unhealthy. And I think this one is not cached, right? These visits, because this is when we track like the clicks. So that doesn't work. So shall we scale it back up and unbreak it?
Yeah, let's do it.
Live? Okay. Scale up. Odds namespace. So odds and going through its status. So L. This is one of the things which it does always. It always tries to restore from backup. And it just does like a sync. So it just makes sure that whatever it has, whatever it needs to have, it's already local. So there's nothing backed up which it doesn't have. And then it like does the reverse, which means that if we were to deploy this like on a brand new system, which, oh, I just got my alert. HTTP alert. So that's the one when things aren't working. So it finally noticed that.
Well, I'm still getting a 503. Is that expected right now?
Yes, because it's still starting. It hasn't started yet.
All right,
my alerts keep going. Yeah. So let's have a look. If we go to changelog, grafana.net, we have this synthetic monitoring. Let's have a quick look. This is down. We know this is down, but this is up according to all the probes. Yeah, no, you can't post links. So this one is, let's see, changelog. Yeah, we just need to switch to changelog.com. 100% uptime, look at that. The latency will go slightly higher. Let me go to the last 30 minutes. There you go. See, the latency goes up. But this is still cached. I think we are currently down. Yes, we are coming back up. So changelog.com, if you're not logged in, it will work. Changelog.com. I don't have any cookie, so not down for the majority of the users. Stuff that's dynamic, for example, this one, if we click here, this was cached. Even though the backend is down, this was cached, so it's just served from the CDN. If we were to play, this should also be cached and this should work. Yep, and it does. So our episode is okay. But if we were to, for example, click on some news items, like this one, because this goes, oh, and we're back up. So it must be back up. That must have restarted.
Yeah, it's back
and we
up
are.
now.
There you go. Yeah, so we're already back up. That would not have worked had the origin not been up, because the request, the redirect and the tracking, or like that link was posted. Okay.
Can we look at one last thing, because my curiosity is getting the better of me before we finish. Can we take a look at the requests proto 1.1 status 206 and see if we can see any commonality across the user agents?
Okay, can you say that one more time?
So let's take a look at the logs for the request proto 1.1.
Right, so the logs, request proto, so let me just get it from here. Your agent or a different agent?
Just all requests, so 1.1.
Okay, so I think this is the view that you want. Yes, 1.1, yes.
Yeah, and just the 206s on the status.
The 206s, yes.
Okay. Let's take a look at the user agent. So http_user_agent. Russell somehow managed to get a 206 on HTTP2, which has also thrown that out the window. So thank you, Russell.
Okay. Method path. So that's the agent 206, HTTP 1.1.
So Android, Mac, Windows, Linux. It's all different. I was just curious if it's going to say BMW or something.
I don't know, like X11 Linux, that's Mozilla. Okay, Mac OS, A2, Android, Chrome. Yeah, all sorts of browsers.
Yeah.
206 for HTTP2. Interesting. Yeah. So let's test that. If the protocol is 2.0, we'll see any 206s. In the last 7 days? No. So I think, actually, yeah, I'm not sure why we're not seeing this. Like,
can we try HTTP 2.star just in case? Or just HTTP 2 star?
Yeah, let's try HTTP 2. Nothing where the status is 200. No, we're not seeing any 206s on HTTP 2. Yeah,
Russell, we're not calling you a liar, but we're definitely calling you a liar.
Yeah. No, we can't see them in the logs. That's all we're saying. Yeah, we can't see them in the logs. Yeah.
All right. I think, unless there's anything either of you want to do in the next couple of minutes, I think we can maybe leave that there. I think it's been really fun, and just testing our thoughts and talking about that out loud, I think it's been really good for me to try and understand what's going on, and I'm sure others as well. So
this has been fun. I enjoyed it.
Yeah, one of the things we tried to do was like figure out what was in common between all of the failures, and there were too many variables that we had to poke at, and maybe not all the data. I don't know if we really dug into if it could have been geographically correlated. I'm also curious about the other aspects of the backend, like the database. So I know you say it's static, but I still think that there's room for that Elixir on its way to delivering some static content to try to touch a database on the way. And if not Elixir, then something else. There's also the possibility that there's middle layers of this that we're not seeing captured in this one set of log output. So being able to put all the information together and then sift through it. The answer's out there somewhere, though.
So what I'm wondering is, what about we create a GitHub issue on changelog.com, which captures these thoughts, and then maybe when we have some answers, some good answers, maybe we can do a follow-up. How does that sound?
Yeah, definitely. I think that sounds like a good idea. I'm also going to dig into your cache messes. Those seem to be rather sporadic. I think there's something there. But yeah, definitely something for another day.
Yeah.
So we'll get that issue. Well, someone will open that issue. We'll get it shared in the show notes for anyone that watches this.
I nominate Marques.
Yeah.
All right.
And we encourage you all to come and join us and have some fun working this one out, because
love it.
It's a good mystery. I like it. All right. Well, thank you both for taking time out of your day for joining me. Thank you, Gerhard, for bringing this interesting problem that wasn't a problem but might be a problem. Just exploring and pulling away the layers of this has been a whole lot of fun. So I hope you both have a wonderful weekend, and I'll hopefully speak to you again soon. That's all for now. Bye.
Thank you.
Bye.
See you all.